This video is about green theorem. Okay, green theorem can be write like this: P dx is a line integral on the left. This line integral can be calculated by an area integral. Partial q respect to x minus partial p respect to y dA. Here is the situation. C is this closed curve and counterclockwise. D is a region enclosed by curve C. Okay, we're assuming P and Q are smooth, you can take a derivative, they're continuous. And D is a simply connected region. Then we have this equation, which is called Green theorem. You have to read a book for the proof, okay? I'm not going to prove that here. Now I will give you two examples to show you how to use Green theorem to calculate line integrals. First example. We want to find this line integral x minus y dx plus x plus y dy. Okay. See here is a circle. Okay. Is a circle. The center as origin, as a 2 as a radius. Okay, we want to find this line integral in two ways. One is calculated directly. Another way to use Green theorem. Okay, now let's first use Green theorem. Okay. So for this integral, my p here, right? Let me write here. P here is the coefficient of dx, which is x minus y. Your q here is coefficient of dy, is x plus y. And the partial q respect to x, you treat y as a constant. Give you 1. And the partial p respect to y give you minus 1. You treat x as a constant. So by using Green's theorem, this line integral will equal to d. Okay, d here is this circle. Okay, C, D is a region enclosed by circle. C is this circle counterclockwise direction. Okay, partial q respect to x minus partial p respect to y dA. That will give you 1 minus negative 1 dA d give you 2. Okay, so 2 dA. We know double integral. If your function you try to integrate is 1 there, then this give you this area of your domain, which will be like 2 times pi r is 2 square, give you 8 pi. Or you can integrate this one. Okay, you can integrate by using polar coordinates, say 0 to 2 pi, and 0 to 2 r dr d theta. You are going to find this give you, 2 times that. You are going to find this give you 8 pi. Okay, now let's integrate this one again by using direct method. Okay, just integrate directly. So to integrate directly, we need to know what is parametric equation for this curve. Okay. So again, for the circle, I told you is like x equal to radius times cosine t. Your y equal to 2 times sine t. Okay. And t equal to 0. Okay, this is a circle. T equal to 0 give you a starting point, and t is increasing from 0 to 2 pi. They give you back to here. Okay. So we have to find a dx. Dx is 2 negative 2 negative sine t. Dy is 2 cosine t. Okay, then this line integral x minus y dx plus x plus y dy is equal to from 0 to 2 pi. X there is 2 cosine t minus 2 sine t times dx. Okay, dt here, sorry. dt. Dx is equal to negative 2 sine t dt. And the plus x plus y. X here is 2 cosine t, and y is 2 sine t. Then dy. dy is 2 cosine t dt. Okay, 0 to 2 pi. Let's simplify this. Now, so we multiply that. We got 2 cosine t sine t. Negative negative give you plus. Plus 2 times 2 give you 4 sine square t. Then we both have dt. Okay, I put that outside. Then plus 4 cosine square t. Then plus 4 sine t cosine t whole sinus dt. And these two terms are cancelled. Okay. So what we have is 0 to 2 pi. 8 sine square t plus cosine square t dt, and sine square t plus cosine square t give you 1. So we got 8 dt. Give you 8t evaluated. Wait. Give you 4, sorry. 4 here. 4 here. 2 pi. Okay. So replace t by 2 pi, and minus 0 give you 8 pi, which is the same as what we had before. Okay, this just to verify the green theorem is right. Okay. Now let's do another example. Okay. We want to use green theorem to integrate this line integral. Okay. X y squared dx plus 2x squared y dy. Okay, the C here is a triangle. with the 3 vertices. 0, 0, 1 is 1 is, sorry, 1 is here, 2, 2. Another point here is 2, 4. Okay. So these 3 points make a triangle. Okay. Our C is this 3 lines segment counterclockwise. Okay. So for this problem, my P there, this is a D. Okay, this triangle inside is a D. Boundary of a triangle is a C. P for this case is x y squared coefficient of dx. Q here is 2x squared y. Partial Q respect to x give you, treat y as a constant, give you 4xy. Partial P respect to y give you 2xy, treat x as a constant. Okay, by the Green theorem, this line integral is equal to this area integral with partial p respect to x minus partial q respect to x, partial p respect to y, dA, which is d 4xy minus 2xy dA, which gives you d 2xy dA. Okay, how do we integrate this double integral? So to do that, we need to find these 2 curves. This one, okay. This is a line, okay. It's not hard to find. The equation for that line is y equal to x. And similarly, you can find the equation for that line is y equal to 2x. Okay. I give you 2 points. You should know how to find the equation for line. Okay. Therefore, this line and this area integral can be right 2xy. Let me get dy go inside, dx go outside. Okay. So you project this region on the x-axis. So your x obviously from 0 to 2. Okay, to 2. Then you fix x in between. Then your y should be bigger than this, which is x. I give you x. Then this point is x. And bigger than this and less than that. That will be 2x. Okay, 0 to 2. Integrate this respect to y. You treat x as a constant. So 2y, you integrate that, give you xy squared. Evaluate an x and a 2x dx. 0 to 2. Replace y there by 2x. So you got a 2x squared minus x squared dx. Zero to 2. So you got a 4x squared minus x squared. You got a 3x squared. Then you got a 3x to the third dx. Give you 3/4. X to the fourth. 0 and the 2. Give you 12. You can use you can integrate this one by direct method, but it's taking you a long time to do it. Okay.